Let's talk about reliability and types of error. I'm going to talk about two types of error, trait and method. What do I mean by reliability? Reliability is when you measure the same thing twice and you get the same outcome. It's not like you measure something, you get -1 one time and you get +1 the next time. That would be low reliability. So when the test or the questionnaire or a rater, if it's an actual human giving a number for something that's being observed, measures the same thing more than once and gets the same outcomes. So we want to have high reliability. But unfortunately, reliability is never perfect because there's always things that interfere. And that's called, when there's things that interfere, that difference is called error. And so, unlike validity, which you can't actually get a number for, reliability you can. It's kind of like a correlation. 0 is no reliability, and 1 is perfect reliability. So if you measured two things twice and you got the exact same number every time you measured uh, uh, things twice, you would have a reliability of 1. Now we'll look at different types of reliability a little bit later in another video. Now, what do I mean by error? Error is the difference between the true and the measured score. Now, the measured score is like if somebody gives you a Likert item, it says on a 1 to 5 scale, going from strongly disagree to strongly agree, how much do you agree with the following statement? I like candy. And you choose 4 for agree, but you didn't choose strongly agree. And the difference between so that was a measured score, what you actually put, but the true score might be different. Now, why might the true score be different? You might kind of be between agree and strongly agree, or maybe you wanted to be strongly agree, but you didn't want to admit it. So there's error sometimes in the measurement. So the true score, how much you truly like candy, plus the error would be the observed score. So if it's the true score, how much you really like candy is 4.5, the error would be minus 0.5 to equal 4.0, the observed score. Now we're going to talk about two sources of error. One is called systematic error or method error. Now suppose the item wasn't I like candy, but suppose somebody wrote the item who came from a country where they call candy, or that's what we call it in America, they call it sweets. So they had the sentence, I like sweets. Now, if you're American, you might think, well, that's kind of broad. I'm not quite sure what they mean by that. And you might mark something differently than if you knew what they meant by if they had said candy. So that's called method error, systematic error. That's an issue with how it was designed. Other type of error is random error or trait error because it depends on the traits and characteristics of the individual. So like I said, maybe you don't want to admit how much you like candy, or maybe you're really full and right now you don't feel like candy, or maybe you're really hungry and you would die to have candy. All of that would introduce what's known as random error or trait error. So those are the two types of errors that can make the observed score differ from the true score. Now let's talk about method error more in detail and give some other examples. So method error results from the way that you design the survey, the way that you're measuring whatever variable you're trying to measure. Suppose that you are rating people's friendliness in an interview or something. Method error might be that the rater is in a bad mood today. So it doesn't have anything to do with the error coming from the person we're trying to rate. It has to do with the rater. Or maybe people were given different versions of a survey. Maybe some people were given a survey that was printed on white paper, and others were given a version that was printed on blue paper. Well, the blue paper might make them think of things that are more cold. That could influence their responses. Maybe the weather's just really nasty one day and a control group is measured on an exceptionally hot day, but the other group who's getting a different experimental treatment is measured on a cold day. That could interfere with the results. Or again, the sample is not representative of the population. Well, some solutions. One of the best ways of doing it is to use multiple measures of a construct. Don't just ask one question, like how much do you agree with the statement? I like candy. Ask both I like candy, I like sweets, I like food that has a lot of sugar in it, I like to eat things where sugar is the main ingredient. Those are all ways of describing candy. And so if you kind of describe it from different perspectives, um, you'll the the method error will cancel out with each other, and you'll end up measuring the pure idea behind what you're trying to get. So that's why when you take surveys, it seems like they ask the same question several times. They're trying to get it so that everybody basically understands what's happening. This is going to be called internal uh, uh, reliability when we talk about it later. Then you also want to design your research so that factors that influence your dependent variable, apart from the independent variable, are minimized. You just don't get a lot of things interfering, especially that might differ at different times and mess up your results. So that's method error. Now trait error, that's that's that results from factors that vary within participants and how participants are different. For example, some participants might be in a bad mood today, some might be in a good mood when they fill out the survey. Some participants can't understand the survey, some can understand the survey. Uh, some are in a hurry and they mark all center scores. They just go down the middle, or they do all strongly agree or all strongly disagree. That would be an example of trait error. Um, and like we said with the jelly bean or the sweets, uh, people might understand the questions varying in different ways. Well, one of the solutions for this is, if you're doing an experiment, is to make sure you have random assignment and you don't choose different people for different conditions uh, that are in different moods or different characteristics. If random assignment will cause the things to just kind of all cancel out. Um, the correct design and making sure that you're using measures that are known to be reliable, that really do measure what you want to measure, and then increasing the sample size. And the people in the bad mood will cancel out people in a good mood, and a lot of things will just cancel out. So when we talk specifically about surveys, what can we do to increase reliability? Well, like I said, increase the sample size, increase N, get a large number. Typically, we need around 300 surveys for to cancel out a lot of the random error. Um, Secondly, make sure every item is clear. All measure each item with several items, and we want to, if possible, use scales that have already been tested and demonstrated to be valid. Um, do your best so that participants respond under the same conditions. If there's some natural disaster going on, it might not be good to mix everybody together. You might want to keep people separate. Um, you want to design your scale so that the average is near the midpoint. Because if most people are answering strongly disagree, or most people are answering strongly agree, we're not going to get a whole lot of variation, and um, that introduces just a lot of error there, because even though people are different, they're giving the same response. and then make sure everybody receives the same instructions, because our instructions can influence how people will respond to the answers. So those are some ways to increase reliability on surveys.